Hello everyone, welcome to our course Reinforcement Learning. As part of this course, in this lecture, I am trying to explain implementation of greedy algorithms, epsilon greedy algorithm or randomized greedy algorithm, which will balance both exploration and exploitation using Python programming. Okay, so to write the code, I have considered the same case study that I explained earlier. So I have the three missions in a casino, and I have to implement this eGreedy method, which help the players which mission to choose. Okay, so first thing what I want to do is I want to feed the initial information like how many missions are there, what is the name of the every mission. Let's take m equal to input enter number of we're getting in number of missions, and because it is a number we have to do the typecasting and create a missions empty list. Now call every mission, so I want to change the code slightly for mission for I in ranges, I in range of m. So loop will be repeated for the m times. If number of missions are 3 times it will ask name. Number of missions are 5 times it will ask the name. So name, enter the name of the mission. So we enter the name of the mission, that will be appended to the missions list and that will be printed. It is asking number of missions are 3. Now it is asking the names. First mission name A, second mission name B, third mission name is C, A, B, C. Next, once ready, now what thing is, if you want to implement the epsilon greedy, so we require some knowledge base, we require some previous inputs, we require some previous returns, at least one return we need for every mission. So how much return are given by mission A till now, how much returns given by mission B till now, how much returns given by the mission C till now. But we don't have a data. So what I suggest is, maybe the one who worked in that casino, he go to mission A and play with that one, and he got some knowledge about the reward. Later he play with B, got some return, play with C and got the return. So these initial values can be used for the future estimation using the eGreedy or epsilon greedy or randomized greedy method. So first, that database collection we will work on it. So for that purpose, import numpy as np. So what I want to do is, I want to store the information. That means how many number of times each mission was played and how much return every mission got, and what is the estimated returns Q for every mission. So I want to create 3 tables. Every table we have the 3 rows because we have the 3 missions, and number of columns, that is depending upon the how many that is our wish, how many database you want to maintain, for how many games, how many place database you want to keep. So here I want to keep number of place number of place as 5 number of place. That means 5 times data I want to keep. For example, you can increase the more. So now you have to create all the tables, number of place by each mission data I want to keep here, like zeros array with m rows, number of missions 3 rows, and n place 5 columns. Similarly, we go for the reward that's equal to np dot zeros of number of missions rows, number of place, that's equal to columns. Similarly, we can go for the q, that's it, initialize randomly, with zeros. Now next task is, we will go, that means the one working in employee, he went for every mission A and mission B and mission C. He take the return and entered into the database. Which database? You have to update all the NR and Q. So you can see, take the mission A from the missions, mission B from the mission, mission C from the mission. It's splinting, play with the mission. Now it will once he played with the machine, he got some returns, right? He got some reward, so that reward should be collected. So R equal to input, how much reward he is getting with that machine, enter reward. Now we have to convert that reward or return into integer. Done. Now what the thing is, we have to update this table. Okay, so what I have to do is, if I take the machine A from the machines, so what is the index of machine A, corresponding row should be updated. What is the index of the B, what is the index of the B in the machines list, that corresponding row from the N will be updated. Similarly Q will be updated. That means we have the machines list. If A machine is there, what is the index? 0. So 0th row in the N or Q will be updated. Similarly, if the machine is B, then index 1 row, that means second row will be updated in the number of place array and rewards array, and Q, that means estimated rewards array, should be updated. So that is coming here. You can see, take the ID of the corresponding machine, and for the corresponding ID, first 0th play, that means the 0th play will be done by the employee to get the information. That 0th play, but we can't get the 0, I entered it as a 0 one time. That means whenever the play was done by that machine, we updated with 1. In the first play, 0th play, which machine is the machine M is played, then that machine M, the value will be updated as a 1. So similarly R value. But coming to the Q value, we have to update like previous Q value, so that's equal to 0, right? So maybe I can, so previous old values for every machine, I want to maybe Q old of every machine, maybe we can consider the 0, 0, 0. 3 machines, previous values are zeros only. That value you have to call here, Q old of 0 plus reward minus Q old of 0 divided by, so number of plays currently, that is equal to only one play, by divided by 1 by n. That's it. So now we will see how it will work. So play with machine 1, enter the reward, play with the machine, enter the reward, maybe 3. So it is going some error, yeah, sorry, it is R, it should be R. So machine maybe 3, later machine 6, later with machine C, that's equal to 5 returns. Now you can see the reward for the machine 1 3, machine B 6, machine C 5, whereas here for the machine 1 one time played, machine B one time played, machine C one time played, and estimated reward for the machine A 3, machine B 6, machine C 5. That's how it is updated. The first index is the 0th index corresponding to the play 0 done by the employee. Clear. Now coming to the users. So we will apply the epsilon greedy to suggest the user which machine should pick. Okay. So for that purpose, this is the random, right? So import random, done. So epsilon assume as a small value, that's equal to 0.2, and random number you can generate random dot uniform 0, 1, 0, 1, and so R value generated. Now what we have to do? So this process will be repeated for all the plays. Let us assume I am the user entering to the casino. The employee will ask how many plays you want to, how many times you want to play. Maybe I may say that number of plays equal to 5. That's already mentioned. I said number of plays equal to 5. Okay. So now we have to repeat that one. So current play, that's equal to 1. Okay. So for but see, we have the number of plays 5, that including the what's called employee payment at the employee play at the starting to collect the knowledge. So that means if you are giving the n play equal to 5 means, so user is asking 4 times. One time is already updated by the employee. Next 4 times we are going to estimate and we have to suggest. So play equal to 1. Okay, play equal to 1 starting from 1. And now I have to write while, this will be repeated, while play less than or equal to n plays, right, n plays minus 1. Minus 1 only. That means 1, 2, 3. We have the 5. So 1, 2, 3, 4. Okay. So these are the 4 and already 0 is there. Total 5. So number of place we mentioned as a 5 here. We have the only 5 columns. Na? 1, 2, 3, 4, 5. So first column is already updated based on the information given by the employee. Remaining 4 are empty for the users or players. So 4 are empty. That means n place minus 1, 4 are empty. Okay. Now, what we will do now? If yes, r is less than epsilon, we are going to the explore. Now we have to choose the random mission. So this is the greedy. Greedy means we can choose all the missions. From first mission to last mission, we can choose all the mission. So rand integer from 0 to m. So you can choose 0. So you can see what is the values you are getting otherwise. Control C, Control M, you can try 2. Again if you try 0, if you try 0, if you try 0, if you try 1, if you try 2, if you try 0, 1, 0, 1, 2 you are getting, because we have the 3 missions. Na? 0th mission, that is A, 1 mission, that is B, 2 mission, that is the C. That's why you are getting the 0, 1, 2. So randomly pick any mission to explore. So that means here we are including the mission which gives the maximum return also. So you got the ID. Once you got that mission ID, so then we can write print format string play with machine. You can write whatever the mission is there under missions. What is the ID you have? You can say with that ID that mission we are playing. Now getting the reward. So you can take reward value r equal to. So you are playing that mission, that what it is suggesting based on the exploration. So input enter the reward. So after entering the reward, do the typecasting. After typecasting, you have to update the that means number of plays matrix and relay that means reward matrix with the current reward for the current mission for the current play. And similarly you can do. But here you have to take the old one, that means play minus 1 you can consider. So here it should be a play minus 1. And here you have to consider the sum. For every row, if the machine is played, then you got the 1. If the machine is played, you got the 1. If you sum it all, whatever the ones are there, all are added, that will represent total number of plays. So that's why I want to write here np dot sum of yes, np dot sum of n of this is for a corresponding ID for the corresponding mission row, all the columns you have to add. For the corresponding mission A, all the values in the column add. Corresponding B, all the missions in the row should add. For C, all the values in the C row should be add. So corresponding ID row we have to add. Now, yeah, Q value is there. ID is updated. I think it's not required actually. I mean, one more thing. In place of Q old, you can use the Q only. From the Q matrix, previous column will give the old value, current column will give the current values. So you don't need to take the old here. You can take the Q only. Fine. I think it's fine. So it is giving n r q values repeatedly. Now we will go for the else. In else condition, now we can go for the print explore. Then here what to do? You have to take the maximum. Yes, id equal to np.argmax of. So what is the highest return? Highest return in the previous play. It should be colon comma play minus 1. So all the rows from the previous play take the maximum index. Based on the maximum index, we can easily identify the which one we are going to pick. You can copy the same code again here. So we have to play with that ID, that machine which has the maximum return in earlier. So it is the exploit, not exploit, it is the exploit. Yes. So play with mission ID, enter the reward, and you are going to update play one. That's fine. So everything completed, and finally you can print all the values, like print number of plays information, print reward information, and print queue information, estimate queue information. So see how it looks. I don't know. So exploit with this is the current values. Now it's showing that exploit with machine B. So it's come to the exploitation stage, machine B. Maybe this time let us assume the reward is equal to 7. It is going some error. So what's the error here? Queue of ID of play equal to here it is not a queue of ID comma play minus 1. Corresponding ID we have to corresponding machine we have to consider the estimated reward value. We take the previous estimated reward value for the corresponding machine. That ID you have to pass. So once again we will start from here. So reward of the machine like 3, 6, 5. It's updated. Now come to this point, greedy optimization. So explore with B. So even we know that B has the highest return. So acceleration, we consider the highest reward mission also. That was not in the modified. In the modified, we will exclude the highest reward mission. But in the greedy, we include the highest reward mission also for the exploration. That's why you are getting B, explore B. So let us assume it is a 7. Still it is problem. Setting an array element with a sequence. Where it is. Yeah, sorry, it's again problem, same thing, ID comma, and here also ID comma, done. Again run this one. So enter the reward, that's equal to 3, for B 6, for C 5. Now run this one. So exploit with machine B, maybe 7. So again exploit with machine B, I am getting 8, let us assume. Again exploit with machine B, this time I am getting 1, let us assume. Now exploit with machine B, again I am getting 1, let us assume. Yeah. Actually the problem here. The problem is it going for the infinity loop because the play is not updated. It going for the infinity loop. That's why actually we are saying that number of plays are 4. That means if you include the employee play, so remaining plays are 4 only. User plays are only 4, but it is asking 1, 2, 3, 4, 5, like that continuously asking because we are in the infinity loop because your play is not updated. So just simply stop this one. So you have to update the play. Play equal to play plus 1 update. Okay. So hope it will work now. So again start from here. Enter the values like A3, B6 and C5. This is corresponding to the number of rewards data of each machine. Machine A reward is 3, machine B reward is 6, machine C reward is 5. This is the number of plays on each machine. Machine A one time, machine B one time, machine C one time played. And this is the estimated Q value for the machine A, for the machine B, and for the machine C. Now, coming to this point, now run this code, already explained. So, exploit, it is saying that exploit, that means whatever the R value generated, it is more than 0.2. So, we are coming here, exploit. So, machine reward it is asking, maybe let us assume it is 7. And again, for the second, first play by the user, second also it is suggesting go with B only. So maybe this time I am getting 10. Let us assume. So this is, you can see here, this is the employee. I did a small mistake. I will tell later. N is the number of plays. So you can see here machine 1 played 1 time, machine 2 3, machine B 3 time, machine A 1 time, and machine 3 1 time, and 72. So and one more thing, so if the machine A and C not participated for the next play, because only B is participated, you keep the same values for the next play also. So you update the which machine participating, and for the remaining machines copy the same return, future returns. So that's one thing I missed here. So I will update the code. Now where we can update the code, this part. Yeah, here I will update. So what it is saying that q value of all the machines of the corresponding play is equal to, so previous one we have to update, that's it. This is a random, that's fine. So we have to update. Then what happened? So see, B is participated, this is updated, and whereas for A and C the same value will be reflected here, same values will be reflected, right? So, and one more thing what I missed here, it is not a small r, it is only reward will be printed, but it is a matrix I want to print, so it is a capital R. That's one thing missing. Okay, and for easy of understanding, what I want to do is print 50 times, and print I can write number of times, or you can write the participation of machine in each play. So whether in a particular play, which machine is participated. If any machine is participated, that is updated with 1. So play means every column represents one play, and you can use this one as it is, and keep copy, and this is about the rewards. You can write rewards of each machine, rewards of each machine. Here also rewards of each machine in each play. This is also fine, and this is about the estimated future rewards of each machine. Get it? Okay. I think everything looks good. We'll see how it looks finally. So run it again. Machine A started 3, machine B 6, machine C 5. It got the returns. Now run this part. Now exploit. Go for the machine B. Let us limit the 7. Now it is exploit again B1. So it's getting values. So only 2 times participated that machine, and no machine is participated. Machine B participated 2 times, and remaining machines are not participated. And these are the rewards. When the machine B participated 2 times, these are the rewards getting 7 and 1. And this is the estimated rewards. These are the estimated rewards. So maybe so like that we can get user. And next thing is I think I missed something. Why? Yeah. Why it is asking only 2 times? Play equal to 1. Number of plays, how many number of plays I have considered? 5. So this should be repeated 5 minus 1, 4 times. So 4 times means play equal to 1, updated, becomes 2, next 3, next 4. Should ask at least 4 times, but it is asking only 1 time and 2 times only. We will check once, please. So I observed actually it is n play 5. So here you can see I used n plays. It is a not place, it is a play, n play. That's why even though I mentioned user should play 4 times, sampler should play 1 time, total 5 times, but the user saying only 2 times. Now we will run once again, mostly to the last one. So 3, 5 and 6, let us zoom. Okay. So now you can see highest return is C as of now. Now go to this code. So explore B, maybe it's getting the 2. Next, explore C. C is the highest return. But when it is a greedy algorithm, during the exploration also we can use the highest reward machine. That's why C is coming here. But where in the modified greedy, C will never come during the exploration. C will never come in the exploration. So fine. And maybe you can see C equal to 6. It's getting some error. Where it is? True value play. Still it is mistake. Here the matrix is Q, not Q value. Okay. The matrix is Q, you can see. It is a Q matrix, Q, Control C. So wherever you have the Q value, you have to update. Control V, Control V. It's fine. Remaining all are fine. Looks, yeah, fine. We will see now again. Run this one and enter the 3, reward B6, reward C5. Now run this one. Mission B, exploit, highest reward mission. Exploit means highest reward, that's the B. So maybe return is 7 when played user. Now it is suggesting again play with B. Maybe this time he got 1, let's assume. And this is user 1 time, 2nd time, 3rd time. So you can see exploit highest reward B, exploit highest reward B. When reward 1, maybe the mission C will become a highest reward estimated value. You can see in the next final matrix, we will see. So maybe this is about the 6. Play with mission C, then it gives the 6. Then again play with mission C, exploit highest reward, and this is the 4. That's it. It will print everything. Right? C. So, but you can see here. So this is the first column is the play by the employee, 0th play. In the first play, it is suggesting go with B. Reward is 7. Then estimated is 6.5. Now in third play again suggesting based on exploitation because it has the highest reward exploitation and suggesting go with B. Then reward is 1. Then estimated value becomes 4.6. Now 5 is the highest value. Now that's why in the fourth play exploit because of the highest return C goes. Now based on this reward 6 you can see reward is 6 and this is the 5.5. Now here 6 is coming so C updated. Here 7 and 1 B updated. This represents the how many times in first play all missions are participated. By the user first play B mission, second play B mission, third play C mission, fourth play C mission is participated. So this is how we can estimate the rewards. We can suggest the user which mission to play, which mission to go to expect the more returns. Hope you understand. And after multiple revisions, multiple corrections, this is our final code for the greedy optimization. So hope you understand, and in the next lectures, we will discuss with some other concept. Until then, bye. Thank you.